All right, hello and welcome to episode 4b of the SOC Level 2 pathway of TryHackMe. And this is actually a continuation from our last video. So the last video that we did was the Splunk Exploring SPL, and at the very end of that video, there's a portion at the conclusion where it says do all of these other rooms, and these three I've already done, and there's videos of these three rooms inside of this channel. So if you go do incident handling with Splunk, investigating, or benign, any of those things, if you search inside of the channel contents, you'll be able to find them. This one I have not done, which is the PS Eclipse exercise. And this is it. It's literally just a bunch of questions that we got to answer based on a particular scenario, and we're going to be doing some incident handling and some investigations, so on and so forth. So that's the entire purpose of this video today. And what's really fun about it is that this is actually a free room inside of TryHackMe, which means you don't need a paid subscription for it. You can just sign up for a free account inside of TryHackMe, and you can get access to this room, which will give you even more experience with Splunk, which is pretty much the whole purpose of this. And if you're studying to become a security analyst, you need to know how to use a tool like Splunk, which is I mean, it's honestly, priceless in my opinion. So this is one of the many reasons why I love TryHackMe, because they have all these free rooms, and there's hundreds of free rooms, and this happens to be the one that we're going to be working in today. So without further ado, let us jump into the scenario of this room. Okay, here's the scenario. You're a SOC analyst for a managed security service provider, an MSSP, and the company is called TryHackMe. A customer sent an email asking for an analyst to investigate the events that occurred on Keegan's machine on Monday, May 16th, 2022. So that's the date that we're going to be honing in on. And Keegan seems to be our user. So it said that the machine is operational, but some files have a weird extension, and the client is worried that there was ransomware attempt on Keegan's device. Your manager asked you to check the events on Splunk to determine what occurred in Keegan's device. So definitely Keegan is our user. The date is going to be Monday, May 16, 2022. And I think the index is going to be TryHackMe. Basically, it's going to be our source of information. And from there, we're just going to go through this and answer all of these questions. So I've already started the virtual machine right here, which is done through the Start Machine button right here. And I'm using the attack box that's inside of TryHackMe, because they have a really good attack box that you can use and for free if you use any of their free rooms. But if you wanted to use your own machine to connect to the TryHackMe server, you would need to do OpenVPN. So you got to download OpenVPN and set it up so that you can connect to this virtual machine right here and get access to the free Splunk instance that we have right here. But all of that has been done for me, so we can just jump into our investigation here. Okay, cool. So the first thing that we got to do here is we got to actually click on search and reporting so that we can try to find our index, or the source of our data, basically. One of the great ways that you can do this is you can either go through search history and you can start implementing filters yourself, or you can click on this data summary button that's at the bottom right here. And when you click on that, it'll give you a variety of tabs to work with. So the first one is going to be host, the next one is going to be sources, and then we got source types as well. And what's useful, so host is going to be, this is our host, and it has 17,000 items. So this is most likely the host itself that's in question. We have these various sources. So you have the security, you have Sysmon, which is probably, it's actually a really good source that we can think about right here, because Sysmon has not event IDs, but they have event codes that you can filter by. You have the network interface, so on and so forth. So I think Sysmon is a good one. And then we have source types, which is exactly the same thing as sources. So the Sysmon, our operational source code, source right here, is a good place to start from. And then from there, we can start filtering in more and more and more. So let's close this, or actually if I click on this, I wonder if it'll just load everything for me. So we have everything right here. It says the last 24 hours in the corner right here. So obviously that's not what we want to do. So what we do want to do is we want to do all time, just to get a good idea of all the events. So it's going to be 7,000 events. And then from here, there's also a specific date that the incident applies to, which is May 16th, 2022. So now I want to hone in even more, and I want to go into the date range right here. And in the date range, I'm going to go between right here. So we got May 16th, 2022 to May 16, 2022. And it'll give us from 000 to 24 hours. So this is the full 24-hour cycle, and I apply that, and it comes down from 7,000 to 3,700. So that is pretty decent. So now we have a decent range of data to work with, and we have some event codes that are useful for us. So if I go here and I look at these various event codes, I don't know any of these by heart, but we do want to, I mean, you can always Google this, and this is kind of my default rule as well. It's like to Google what various event codes mean. And so we have 1, we have 3, so on and so forth. So there's 11 event codes, which is not bad. But instead of doing what does this event code mean, what you can do is, what event code is assigned to this kind of activity. So that's what I'm going to do, basically. I'm going to Google it, and I'm going to try a few different Google searches to try to see what event code would be associated with downloading things. That's basically what I'm trying to find out. So let's see what we can find here. All right, so a few interesting things came up. The first one actually was this one. Where is it? Oh, I used Gemini for it. I asked Gemini what were the event codes that are associated with downloading files, and it gave me event ID 15, event ID 11, and from our list right here, we don't have an event ID 15, but we do have an event ID 11, but there's a lot of counts. So there's 700 events that are associated with that. So that one might not be my first, but then there was another one that when I went to Google and I just started searching for things, something called network connection. So a network connection is essentially something else that is relevant to downloads because you're connecting via the internet, which is considered the network. So if you make a network connection, it could be anything like a TCP connection or a UDP connection, and those types of connections sometimes are associated with downloading things, which is event ID number 3, which is a network connection. And this is a little bit more promising. So if we go here in our event codes right here, we see that there's event ID 3 or event code 3, and it has a smaller number of counts. So it has 300 counts. And now we can hone in a little bit more as well. So here's what we can do, right? So if I do event code equals 3 and press enter, I'll see that there's 301 events. But then there's also something else that we can do, which is the user. So if I do and user equals, I'm going to do asterisk Keegan, because there's something in front of Keegan's username, right? So it's not fully Keegan. If we actually go to the users right here, it's usually never just Keegan. There's something in front of the username, which is the device name itself. So we know that the username is Keegan, and we know that the event ID that we're trying to search for is event ID number 3, and it went from 300 events down to 4 events. So this is much more promising in this case. Now we can kind of start searching through these 4 results that we got and see if there's anything interesting in these 4 results. I'm actually going to open this thing inside of a full screen to make it a little bit easier for us to analyze this information. So now what we got is these 4 events, and they're all on one screen easily like this. So let's see if there's anything interesting that shows up here. Okay, so the one thing that you could do is obviously you could literally just try to visually analyze all of the data that comes through this stuff right here, but it becomes a little bit tedious. Even though there are 4 results, imagine if there weren't 4 results, and imagine that, you know, there's hundreds of results that you got to go through, and there's just too much data for you to sift and sort through visually yourself. So what we can do is we can start implementing some other filters. So at first glance, even if I just click on image right here, there isn't anything that is really that concerning. So you have a PowerShell execution and you have a OneDrive execution, and these aren't really that concerning with these 4 events that show up. So what we can try to do is we can just remove the user Keegan, and we can try to look at some other data. And then kind of an easier way to look at things is through the table command. So if we do table, and then I'll just do image, for example. If I do table and image, oh, just from the very beginning, there's something called outstanding gutter .exe, and then outstanding gutter.exe seems to be, I mean, very prominent. So it seems to be that a lot of results coming just from this one particular thing. So we can add another command in here, which is the stats command, and you can do stats count, and you can do stats count, and then let me see, count as let's say callouts by image, and then do the table of the image, and then there we go. So we have these things, and let me see if it gives me it doesn't do the count of it for me. So let me see if I can find the various counts. Oh, you know what? I got to do the table image, and then I got to do callouts. So the count is going to be called callouts. Basically, that's what we're doing. So I could just do counts by itself as well. So there you go. Now we can see, instead of seeing just a list of all these things, you can see that there's these 4 different images that have shown up. And then from those 4 different images, there is 291 callouts, or 291 counts. And I could just, I can remove this just to make it a little bit easier. So if I do count by image, and then do image, and then we'll do count like that, just like that. So it'll show you the count just to make it a little bit simpler. So that's what the number of instances that have shown up for all the different images inside of our event code right here for outstanding gutter, PowerShell, OneDrive, so on and so forth. So outstanding gutter just by itself seems to be questionable, and it's inside of the temp folder, which is even more questionable because typically that's where stuff like this would reside in. But we need to confirm this. We need to verify that our suspicion is actually correct in this case. So what we're going to do is we're trying to hone in on this particular result and see what has to do with this thing, if we can find the actual query or the actual command that resulted in this. So let's see what we can do to find that now. So the first thing I want to do is I want to copy this particular command, which is our PowerShell command, because PowerShell is usually associated with actual commands that have ran and various connections that can be done. You can download files via PowerShell, so on and so forth. And if somebody has hacked into a machine, they're most likely not going to be hacked in via some kind of a RDP. They'll probably be connected through some kind of a reverse shell or some kind of a command line instance. So we can go and we can actually search through all of the results in this particular case, and we need to fine tune this. So I can do command line equals anything, and then I can do the image equals our image for PowerShell, which image is essentially another word for process. So you can do command line equals everything, and then the image would equal to the image that we have for PowerShell. And in this case, nothing is showing up because we're honed in on this particular date. So if I went to all time, let me see if I can find everything under all time for this particular result. Let's see. Okay, so this is another little trial and error kind of a thing. So initially when I pasted in the image, there was only one backslash between all of these separators right here. And this is something that I just found through Googling, that you sometimes, or maybe even more often than not, if you put 2, because when I did just one version of this, and this is basically what the command looked like, right? So there was only one version of it where there was only one backslash between all of these things as separators, and nothing showed up. So if you add the second backslash, then the results actually start showing up, which is interesting, and I'll have to learn why that actually is. And I'll do like a little bit of a search with Gemini so that we can understand why that actually is. But now we have some results, and the results are now 5 events, and most of these are on 5/16, if not all of them. So they're all on 5/16, which is the date in question, which is still very promising. So now we can click on the command line to see what commands were ran. And so you have the very first, the first one, which just seems super freaking sketch. That seems like a sketchy type of a command. Then you have the Windows PowerShell version 1, no logo, no profile. So this doesn't seem to be a really big deal. And then you have no exit command, output encoding. That also doesn't seem like a big deal. So this is highly questionable. So what we can do, because this looks like a base 64 encoding. So if I'm going to copy this, and I'm going to open up a new tab, and I'm going to open up CyberChef, and I'm going to decode that from base 64. So I'm going to paste that entire thing right here, which you'll see it gives you an output right here. And then from on the left side right here, we have something called from base 64. So we want to take it from base 64 encoding and turn it into this. And then from here, what we're also going to do is we're going to, I think we need to do from, let me see, maybe there's another decoding that probably needs to take place. So let's see here. Okay, so two things. Number one, I removed that initial portion right here. So the PowerShell.exe, etc., because this is not base 64. That's actually regular command. So if we delete that, and then we add another piece right here that decodes text. Now the encoding originally was UTF-8 65001, and I changed it to UTF-16 LE 1200. Now the main reason for that is if you see this just by itself, so if we didn't include the decode text at all, so if I just turn this off, you'll see that this kind of looks like regular legible things. So it says set M preference disable da 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 da. So we need to decode text now, so that it's fairly legible, but it's not fully legible. So if we do UTF-8, it shows us this. If we do UTF-7, same thing. If we do 16, all of a sudden it turns into a legible piece right here. And then we can now see the full-on command that shows us what they did inside of that PowerShell command. So set MP preference, disable real-time monitoring, true, and then they made a wget command from this specific URL where they downloaded this outstanding gutter, and the output file was also outstanding gutter, and it's inside of the scheduled tasks, or excuse me, they separated it and then they created a scheduled task that would run this executable, so on and so forth. So the executable seems to be this thing that was downloaded, and it's a binary. So if we copy this freaking thing, and if we go here, we will officially have our first answer right here. Boom, it's right here. So now we can move on to the next one, which is what is the address that the binary was downloaded from. So the HTTP address that the binary was downloaded from, which is this thing right here. So this is the HTTP address, and I can copy this because that's where the wget command was from, and I can now remove this as well, and I can go here and I can paste this. But what we need to do is we need to defang this. So we're going to defang the URL and drop that in here, and now it'll defang it for us, which essentially it's dropping these like brackets around all of the dots and all of the main points of the URL. So I'll copy that now, and I'll go here and I will paste that here, and we should have our answer. So let's see. Okay, that works. So it was you just need to remove the / outstanding gutter, etc. They just want the first portion of the URL. So that is the answer for the path that it was downloaded from. That's where the binary was downloaded from. So the next question now says, what Windows executable was used to download the suspicious binary? Enter the full path. And in this particular case, we know that it was PowerShell. So we need to just take that binary. So let me see if I backspace. No. So if I backspace here, it's not going to work. So what I can do is I can go to my browser here, and I can just go back a couple of things to find our path for the PowerShell, which is right here. So it's the C, Windows, yada, yada, yada. This is the full path to the executable that was used to download this thing. And can I copy this or no? If I do Control C maybe. So let's see if Control C works. There we go. There you go. And so we used PowerShell to download it. And it says what command was executed to configure the suspicious binary to run with elevated privileges. And that command is also inside of that, that base 64 encoding. So if I pick this thing back up, so this was the original command that we found. So we take this thing, we will copy this, and we'll go back to CyberChef. We're going to paste it in here. And instead of doing defang URL, we're going to use the base 64. So from base 64 is what the original thing was. And then we're going to decode text as well. This was our full command right here. And we did 16. So this was the encoding. So this was the full command. And now we want the piece that says turn it into a elevated privilege, right? That was what the question was. It says what was the executed to configure the suspicious binary to run with elevated privileges. So if we go here and try to decipher this whole thing. So there was a scheduled task that was created, and this is what the scheduled task was. And then it's saying that this is going to now run it, and the scheduled one event elevated, So we see from here that it was scheduled tasks essentially that created the command, so on and so forth. And the executable for scheduled task is actually literally called SC, whatever this thing right here, .exe. So this piece right here, .exe. So we're going to go to our search bar right here. And now we're going to change our query, our command, right? So we know what the name of the like malicious executable was, which is outstanding gutter.exe was the name of the malicious executable. So we're searching for that, but now we want to use the specific image or the specific process that created that. And I know it's like Windows yada 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 scheduled task.exe, so I'm just going to do an asterisk in front of this to imply that I want everything to be filled in for me prior to scheduled task.exe, and then I'm just going to turn this into a table, and I want the command from it. So this is the full thing right here. So we're looking for this executable, and we want the image or the process that's being used to do it to be the scheduled task.exe, but it's like a full path prior to this, which is like C / Windows / whatever, and it leads to this finally being the piece. And then we just want to turn it into a table, and we want to get the actual column of the command line, meaning the actual command itself that was executed. So if I run this, I got these tasks right here. So we got these Windows tasks. You see how prior to scheduled task, it has the C Windows, so on and so forth. So we have this full thing. Now we are looking for the actual command that created that outstanding gutter, which is right here. So it actually shows it in a couple of times. I think they're using the same command multiple times. It literally seems to be the same exact command, but this is the full command, right? So it has this run, create, run, create, run, create. So it's the same exact command that's just been ran a few times, but this is the command that creates the thing with elevated privileges, and it seems to be creating it with the system. So it says RU stands for run under system. So it's creating it with system privileges. And I am willing to bet that this full thing right here is the command itself. So let me see, maybe we need it without the quote at the beginning. So I'm just going to copy this real quick. Let's see if that works. Yeah, there you go. It worked. So that was the command that was used to execute the suspicious binary with elevated privileges. So now it says, what permissions will the suspicious binary run as? What was the command to run the binary with elevated privileges? And now we want the one with the format of user plus this plus command line, so on and so forth. So this is going, essentially we're looking for the same answer, but now what we want to do is we want to include these two specific parameters in our format of the answer. So this is the actual command that's running it. So we have the command that created it, but this is the command that's running it. And this is the part of what we're doing. So right here where you see it says format user plus semicolon plus the command line. So that's the actual command that we're going to be pasting in here. We just need to find the user that ran it, which is basically the system the system name in this particular case. So we are going to, I'm just going to delete this, and I'm going to go back to all of our events right here. And what I want to do is I just want to find the user that is our system, which is going to be over here. So I'm just going to click on this, and we have these specific things. So it's not translated is one of them, and then we have Keegan, which is the other one. So that's not it. What I want to do, maybe it's under host name, I want to say. Let me see. Okay, so I needed to find the user, and I messed around with a few things, but this happened to be the one that actually got me the username that I was looking for. So I still looked for the outstanding gutter executable, but I just fine-tuned it with user equals, quote, asterisk system, because I know that it's running under system in some capacity. And so this is what we found. We found the actual user, which is NT authority system. So I know that's what we have to do in advance, or we need to put it in front of the command based on the format that they gave us. And then so since that's what I got to put in front of the command, I'm going to copy this, and I can just go back to our last set of results that we got that gave us the full thing, where it was the image dot schedule task, so on and so forth, removing system from it. And so this is the command right here. So we got the C Windows, etc., run this. So this is the full command that's running, and it's running it under the system. So we're going to copy that. So that should be our full answer. So we have the NT authority / system separated by a semicolon, and then we actually put the command line in here, and boom. Okay, so we got that as well. Nicely done. All right, so now moving on to the next one, which is the suspicious binary connected to a remote server. What address did it connect to? Add the HTTP and defang the URL. All right, so since I know that the suspicious binary is called outstanding gutter, and originally it was saved inside the temp folder, so it's inside this thing right here. This is where the actual suspicious binary is. So first I'm going to filter for that. So we're going to do image equals this thing. Let's see if anything shows up here. Nothing shows up. I think I got to do the double backslashes again. I don't know why that happens. I need to find out why that happens. In fact, I'm going to do that right now because I'm really curious as to why it doesn't work like that. So let me find out why we need to do like double backslashes to be able to find this. Because if I do this, yeah, see, it shows it. So I'm really curious as to why we need to do that. So let's find that out. Okay, so here's what we got. So this is interesting. So it says you've encountered a quirk in how Splunk interprets backslashes. So backslashes are used as escape characters in programming languages and search queries like Splunk. Backslashes often act as an escape character. They instruct the system to interpret the following character literally instead of its special meaning. Double backslashes, when you use a single backslash with a string within a string literal in Splunk, Splunk interprets it as an escape sequence for the backslash. This means that it removes the escape character and treats the following character as normal. So for example, our first query, which was the singular backslashes, the single backslash before is interpreted as an escape sequence, which means it removes that character and it turns it into this, right? So instead of it actually being done as C and then backslash Windows, backslash temp, etc., it does C backslash Windows temp, and then for some reason this backslash is still in there, and which is not a valid path. But if you do a double backslash, then it actually provides that. And this is actually super freaking useful, even for me, or especially for me, and hopefully for you too, because when you're inside of Splunk, you need to make sure that you're using double backslashes, because the first one, if it's by itself, it's used as what do they call it, as an escape character. And so if you want the backslash to be included in it, then you would need to do double backslashes so that it actually includes it in your search parameter, and that way you get the results that you want. So this is why we actually get results when we do double backslashes instead of a single backslash. So now that being said, now we have an image that gives us the result of the exact temp folder from what we're looking for. And what we need to do now is we need to try to find the rest of the question, which is what again? So it says the suspicious connected to a remote server. What address did it connect to? And we need to find this. And so let's see what the hint gives us. It says CyberChef can help you defang the URL. So what we need to do is we need to figure out how connections to remote servers are made. And it could be a variety of different things. And in the interesting fields is what I would be interested in searching. So let's try to see what we can find inside of these interesting fields. Okay, here's an interesting field. So there's something called a task category, and there's only 4 items inside of our search results. And there's something called DNS query. So if we do a DNS query rule, and just punch this in here, and it includes in our results, and all of our results, it went from several hundred down to 5. And what we need to do now is we need to find the suspicious binary to a remote server. So that's what we need to find in this particular situation to do that. So let's see what we can find here. Okay, there's a field here, an interesting field called the query name, which very much looks like a URL, and it says ngrok.io. So we can try to just find that. I don't know if, yeah, you know what? I'm just going to do the table thing. I just want to get good at writing these queries. So we're going to do a table, and we're going to do query name. And let's see if that brings it up for us. There we go. So we got it. This is the actual query name, the URL here. And it very much looks like a command and control URL, a C2 server, so to speak. So if we go here and defang this with all the results that we had before, I'm just going to paste it here, and I'm going to turn this off. I'm going to turn this off, and I'm just going to go to defang, and I'm going to do defang URL. And there we go, and we have a defanged URL, and I'm going to copy this defanged URL, go here, and paste this defanged URL, and it's not the right answer. Why isn't it the right answer? Let me make sure I extend my machine because I really don't want to lose time here. That would suck. Oh, you know what? It's because I didn't put the HTTP in front of it. So I got to first do the HTTP backslash or // and that should be our result. So now we can do this, and we can copy this. Oops. Gosh, we can do this. We can copy this and go here and then try to repaste that with the HTTP. There we go. Okay, we got it. All right, now a PowerShell script was downloaded to the same location as the suspicious binary. What was the name of the file? So the downloaded suspicious binary was inside of our temp folder. So Windows temp, so on and so forth. So this is where we want to search for. And I'm going to copy this. That includes actually our 2 backslashes. So I'm just going to do this. See, yada, yada, yada. So copy this. And I'm going to go here. And I'm now going to, let me fix this again so it gives us the full thing. So now we want to search for the Windows temp folder. It's actually already here. So I'm going to do an asterisk behind this to keep that. And we'll just do everything else. And let's see what we can find here. So we have a bunch of images, obviously. So we need to use a little bit of a result here. So we know that we need PowerShell scripts. So the PowerShell script, right? It says PowerShell? Yeah, PowerShell script. So PowerShell script actually has the extension PS or PS1. So we're going to do PS1 as our extension, and let's see, that gives us 0 events. Oh, you know what? Because I'm searching for an image, so I think there's something. So let me see if I do this and just remove that and only search for that. There's only 28 events, and then there needs to be a parameter for downloaded files. Boom, right here. So it's downloaded files is target file name. So here are all of the target file names that we can try to find. So we need target file name to be our search parameter. So target file name like that. it equals to the Windows yada 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 temp PowerShell, and we still have 28 events still, huh? Okay, so I want to see a table version of this. So table target file name, and here's a cool tool. It's called dedup, which means delete duplicates. So we want to delete all the duplicates of the target file name, so we can only see the unique target file names. And so now we have 14 statistics, and we got to find the, what is it? A PowerShell script that was downloaded to the same location as the suspicious binary. And what is this specific one? So let's see what we can find in these results here. Okay, I mean, this is kind of, it's a little bit obvious. So it says script.ps1, so I would say that that's the script. All these other ones, I mean, I guess they can be scripts technically, because everything that's a PowerShell, maybe not. So a PowerShell script or PowerShell file may not necessarily be a script. So that could be, there could be a variety of different things, I guess. But there we go. So script.ps1 is the file name for the PowerShell script, and now we have the malicious script was flagged as malicious. What do you think was the actual name of the malicious script? So let's see. It says check virus total for the hash value of the PowerShell script. Okay, there we go. That's cool. So what we need to do is we need to go to virus total and check for the hash value of this thing, which is a cool version of it. So I'm going to search for script.ps1, and then we're going to try to find the hash of it, because I don't have the actual file inside of this, but I think it should actually show us hashes inside of this thing. So if we go back to just our regular search right here, I think there is something, yeah, there is something right here called hashes. So that's useful to know. There's a hash field for everything that goes on. But we know now that we're looking for script.ps1. So we're going to do target file name script.ps1. There's only 2. And then we're going to pipe this into a table, and we want the target file name and the hashes. So we want the table to show us this, and look at this motherfucker right here. Oof, excuse my French. Got super excited. So okay, so we have a SHA-1 hash value, we have an MD5 hash value, SHA-256, so on and so forth, IMP hash. So I'm gonna try to take, I'll just take the SHA-256. I'm gonna copy that. So now let's go to virustotal.com, and we want to search for the hash value right here. And all right, so we got it. And so we want the actual file name of this thing. Usually it's under details. So let's see what we can find under details. Right here under names, we have all these other names. So we have 523.mal, and then we have blacksun.ps1. So let's see. 523.mal is not it. So blacksun.ps1. There we go. Blacksun.ps1. Boom. All right, cool. Now we got a ransomware note was saved to the disk, which can serve as an indication of compromise. What is the full path to which the ransom note was saved? So we need to have a ransom note now that we need to find. Okay, so we are now back here, and what we're gonna do is we're gonna search for, let's see, I'll do a asterisk, and I'll do 2 backslashes, and I want to do black sun, and then I'll do another asterisk. See if anything shows up here. We do actually. We have a bunch of files, and look at that, a readme.txt file. So really, I didn't do much this time. I just changed the target file name. I put an asterisk in front of it. We did the 2 backslashes because we just learned that one of them by itself would be an escape character. And then I did another asterisk after the fact. I'm just searching for Black Sun. And this is the file right here, or this is the path right here. And it's inside Keegan's directory. So boom, let's do this. And we're going to copy this mofo. And we're going to go here and we're going to paste that path. And boom, awesome. Okay, cool. Now finally, the script saved an image file to disk to replace the user's desktop wallpaper, which can also serve as an indication of compromise. What is the full path of the image? So let's see, maybe there's a, yeah, right here. So there's a JPG, right? So there's a JPEG file that could potentially be our answer. So let's see, maybe if that's our answer. That is the answer, baby. Let's go. We got it. Super excited that this actually worked. And I should not have been zoomed in here because now I'm stuck. But that was it. That was our entire PowerShell Eclipse. Now we know what PS stands for in this particular case, which is PowerShell. So PowerShell Eclipse was the exercise that we just did, the room that we just went through. Super freaking fun. Very, very useful. I loved it. All right, cool. If you found value in this video or if you learned anything, I do encourage and welcome you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video pops up. As I'm recording this, there's already 3 videos that are scheduled to go out, and I just recorded, I think, the second one for today. And then there's going to be, I'm going to try to do at least a couple more recordings so I can do some block shooting so that there's some content that's scheduled to go out. I really, really do want to get to a consistent posting schedule, and especially with a lot of busyness that's going to be happening in the next few weeks and few months. There might be a new job that's going to happen for me, going into cybersecurity or deeper into cybersecurity. So I'm really excited about all the stuff that's happening, and I just want to make sure that I don't leave you guys hanging. So there's content scheduled out. There's going to be new content rolling out. I'm going to be recording content, and it's going to be really awesome, and it's going to be really exciting. So would love to have you as a part of the community. The comment section is always lit, so come and join us. Come check this out. Look, oh, another comment came out literally while I was recording this video. So it's always cool to see people in the community just leaving their questions in their comments and just saying something as kind as "you are the best," which is an amazing compliment. I never get tired of it, and it always brightens up my day. So would love to see you in the comment section. Would love to see you as a part of the community, and it would just be nice to have the community keep growing and turning into what it has turned into. So make sure that you like, subscribe, turn on the notification bell, and leave a comment just to say hi or ask a question or whatever you got. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I hope you got value from this video, and I will see you in the next room. Later.